Okay, we're first going to start talking about transformations of rigid shapes or polygons. Um, so there's a couple of different ways you probably would want to explain things to kids. Now, the visual simpler method is translation. Another word for translation would be shifts or slides. It's where things just move left to right and or up and down. So notice this says that we're going to move 1 unit to the right, 2 units down. So what you could do is have a student put their pencil here, go over 1 unit right, 2 units down, and then this would be marked as, what letter is that up there? Looks like that's a V. V prime. Prime is what you mark the transformation. So the original ones just get the letters, but once they move, they get the prime. Then we would take W and we would 1 unit to the right, 2 units down. This would be W prime. And then U, 1 unit to the right, 2 units down. This would be U prime. Make sure they're using their rulers. And boom, you have the transformation. However, what I also want them to understand is how to do it without just using the visual way. Because let's say the graph isn't there. So if you know, let's say this point right here, V, well, I'll do it this way. If the original is XY, on this one, we're going to move right once, so that's X plus 1. And for all of the Y's, we're going to go down 2. So for V, if V is 0, 1, 2, 3, 0, 5, then here, 0 plus 1, that would be 1. And 5 subtract 2, that would be 3. And yep, right there, that's 1, 3. And so W started off being 2, 0. Well, this says X plus 1. So 2 plus 1 is 3. And Y subtract 2, the Y was 0. 0 subtract 2 is negative 2. So this would be the W prime. This would be the V prime. All right, you get the idea. So you do that on the translations. Now, the reflect. Visually, we're going to reflect across the x-axis. So you look at this point right here. Since this is 1 away from that x-axis, you go 1 away, and that's J prime. So for M, it's 1 away from the x-axis. You go 1 away on the other side. And that's M prime. For L, we were 1, 2, 3, 4, 5. So from the x-axis, we go 1, 2, 3, 4, 5. This would be L prime. And for the K, we're up 4. So from the x-axis, we go down 4. And then again with the ruler, because I'm definitely not going to be doing this right. And then you've got our transformation. But I also want to show you what I want students also to learn. So if you start off with, I want them to learn the mathematical way of doing it. So look what happened. Let's look at the K prime. The K prime is -5, -4, and the K is -5, +4. Well, the only thing that changed, we took that Y value and we multiplied it by -1. And that's when they reflect across the x-axis, not when they reflect over a different line, but over the x-axis, the x value is going to stay the same And the y value is going to be -1 times y. Or you could just put -y. In fact, that looks weird. Just like that. Okay, so now we're going to reflect across the y-axis. So when we reflected across the x-axis, we multiplied the y's by -1, and what do you bet? When we multiply against the y-axis, x's will be multiplied by -1. So let's go ahead and see if that works. So if we call this, if this is b, this is at 2, 1, 2, 3, 4. So if we're going to multiply the x's by -1, that would be -2, +4. So let's see if that's right. This is 2 away. Let's go 2 away. This would be b prime. And look at that. That's -2, +4. So you can, again, show kids visually. C is 1, 2, 3 away. We go 3 in the other direction. C prime. A is on the left side, it's 1 away. So 1 away on the right side of the y-axis. So boom. But this right here is an important skill to have, to do that with each one. Rotations. Okay. So they're going to look funky, right? Because if you think about, if you just have a point, let's say this is the, well, here, let me put it on the axes. Well, a 90-degree rotation could end you up here or could end you up here, depending on if you go clockwise or not. So here is the rule. Does this tell us clockwise? This says counterclockwise. So counterclockwise, the x swaps with y. Then when they swap, although technically this is still called x, this is the new x, this is the new y. Whatever's in the left place right here, you're going to multiply that by -1. Okay, and I've got that note sheet will be down below. So let's start with the r. So the r is -5, -2. And remember, you swap the x's and the y's, and whatever's now in the new x location, you're going to multiply that by -1. So the -2 goes here, the -5 goes here, but then we're going to multiply -2 by -1, so that becomes +2. So at +2, -5, this will be r prime. Let's do the s now. The s is -3, 0. We're going to swap them. Well, -1 times 0 is still going to be 0. So at 0, -3, this will be the s prime. And then finally the t. The t is -1, -3, -3, -1. And then we're going to multiply by -1, so that becomes +3, -1. This is t prime. This one is the most difficult. The rotations are the most difficult to do it visually. So having a strong handle on the mathematics will help. And then this, I'm going to end up deleting this thing here. But down below, I have this posted. And I do not recommend having kids memorize that. Okay, so dilations are when you, like, say in photography, when you either shrink or make a picture larger. Those are called dilations. And so if it says 2.5, that means it's getting bigger by 2.5. So if here's your regular xy, then you just multiply 2.5 times the x, each x, and 2.5 times every y. So every single time. So if it were shrinking, maybe it was 2.5 sizes smaller, then you'd multiply by negative, and that would be a negative right there. So let's go ahead and do this example. So B right there is 0, 2. So we're going to multiply 2.5 times 0, and then 2.5 times 2. So that means 0, 5 is the B prime. So I'll put this in green. This right here is B prime. And again, these are dilations about the origin. All right, now let's do C. C is at positive 2, negative 2. We're going to multiply 2.5 times 2. 2.5 times negative 2. And that gives us 5, negative 5. And that will be C prime. So at 5, negative 5, this is C prime. I meant to put that in. All right, and now let's do A. That's it. Negative 1, negative 2. Multiply 2.5 times negative 1. 2.5 times negative 2. And that gives us negative 2.5, negative 5. And that will be A prime. So right about there will be the A prime. And then I'm going to get my ruler out for this one because that will be too crazy. I shouldn't waste video time trying to make that perfect. Okay, so that's a dilation. All right, I think I'm going to end this video here for the transfer. Oh, nope. I'm going to go ahead and keep going on here on two more problems, or this one last problem. So on here, when we're describing, some of them are hard to tell, but if you have kids notice, these are the same size, and what it looks like is we moved up and over. So that's going to be a translation. So what is the rule? So one way to put the rule is say xy, and then so let's start with the j. We went over 1, 2, and that's to the right, so that would be x plus 2. And then if this is the j height originally, how far did we go up? 1, 2, 3, 4, 5, 6, 7. So we added 7, and that's how you write a rule. And that's all there is to it. Now, would it be a good idea to have the students put the original? Yeah, it would. So the original was negative 1, -4. Oh, I didn't leave much room for that. And we had to add 2. -1 plus 2 is 1. And then we had to add 7. So -4 plus 7 is at +3. And then just have them finish that. But that's how you write a rule. All right, and then we'll do the area ones next.